Hi, in this video we're going to look at how to derive the general term for a quadratic sequence. Here I have a sequence of numbers 3, 6, 13, 24, and 39. And well, we don't know whether this is a quadratic sequence, so obviously we have to first establish that. Now, the general expression for a quadratic sequence is always in the form of an squared plus bn plus c, i.e. n is the nth term, like n could be 1 for the first term, 2 for the second term, 3, 4, and so on. A, B, C are numerical constants, and depending on what they are, it could be 0 or it could be some numerical value, but obviously A cannot be 0, because if A is 0, then we don't have a quadratic sequence. Now, we first need to establish whether this sequence is quadratic or not. To do that, we write down the differences between consecutive terms first, like the second term minus the first term, that's 6 minus 3 is 3. Then we have the third minus the second, which is 13 minus 6, which is 7. Then we have 24 minus 13, which is 11. And finally, we have 15. So this is our first layer of differences. Then we work out the second differences, the difference between the differences, so to speak. So 7 minus 3 is 4, 11 minus 7 is 4, 15 minus 11 is 4. Now, if the second differences are the same, then our original expression or sequence is quadratic. Now, how do we find the general formula for the nth term? Now, if n is equal to 1 in this expression here, in our general expression out here, if n is equal to 1, I get A plus B plus C, and that must be equal to my first term, which is 3. If n is equal to 2, this expression should give me a second term. For n equals to 2, 2 squared is 4, I get 4a plus 2b plus c, and this is equal to 6. Then I substitute n equals 3, so I get 9a plus 3b plus c, and this should equal our third term, which is 13. Now I'm going to label these equations here as 1, 2, and 3. And now we go on. What we need to do is to find what the values of A, B, and C are. So this is basically 3 simultaneous equations with 3 unknowns. You may have come across 2 simultaneous equations with 2 unknowns, but the methodology is the same. Okay, now, to solve these equations, what I'm going to do, we need to eliminate these variables. Well, we need to somehow solve these sets of simultaneous equations, and the method I will use here is what you might have come across as elimination. So first, I'm going to take away the second equation minus the first. So this will give me, if I write this longhand for the first one, 4a plus 2b minus c, and I will take a plus b plus c away from it, so that will become minus a minus b minus c, and on the right hand side I get 6 minus 3, which will be 3. So 4a minus a here, I'll get 3a. 2b minus a b, I'll get 1b. And c minus c, sorry, this must be plus c. C and minus c cancel, and here on the right hand side I'll get 3. Then I'm going to subtract equation 3 from equation 2. 3 minus 2, this will give us 9a minus 4a, it will give me 5a. I have 3b minus 2b, I get this b, and c minus c cancels, and here then I'll get 13 minus 6, which will be 7. Okay, here now I have another 2 sets of equations. We've eliminated the variable c. So I'm going to take away the top one from the bottom one. So 5a plus b minus 3a minus b gives me 2a, and b minus b cancel, is equal to 7 minus 3, which is 4. So 2a is equal to 4, which means a is equal to 2. And notice that this a is half, if I could bring that, it is half the second differences, which were the constant up here. The second differences in our sequence was 4. So the a is just half of that. That number is always the coefficient for a. Well, now that we have a, we can work backwards and find b and c. If I substitute 2 for a in this equation here, either would do. I'll do it in the top one. I get 3a plus 2b is equal to 3. If I substitute 2 for a in this equation up here, I'll get 6 plus b is equal to 3. From here, I get b is equal to minus 3. And from our first equation, we had, if I can bring that down, we had a plus b plus c is equal to 3. So if I write here, a plus b plus c is equal to 3, a is 2, b is minus 3, plus c is equal to 3. From here, I get c is equal to, this would be 2 minus 3 is minus 1, goes the other side, becomes plus 1, so c becomes 4. So our sequence, our quadratic sequence will be, which is in the form of an squared plus bn plus c. A is 2, b is minus 3, and c is plus 4. So this is our quadratic sequence. So here I have written our sequence that we worked out, 2n squared minus 3n plus 4, because a is equal to 2 and b is equal to minus 3 and c is equal to 4. Now just to test that it works, it's always good in an exam situation to test to see whether the numbers fit the original sequence. Now for n equals 1, I get here, that's 2 minus 3 becomes minus 1, plus 4, I get 3. For n equals 2, I get 2 squared, which is 4 times 2 is 8, minus 3 times 2, which is 6, which will be 2, plus 4 will give me 6. And for n equals 3, I'll get 3 squared, which is 9 times 2 is 18. Here I have 3 times 3, which is minus 9. So 18 minus 9 is 9, plus 4 is 13. So we can see that our sequence generates the terms in our original sequence. Now, if we wanted to know what term number 7 is, we would just substitute n equals 7 in the above equation, and we can work out what the seventh term is, which I will leave it for you to do. Here we have another sequence. Obviously, we know it's a quadratic sequence because this is a video on quadratic sequences, but we need to first establish whether this is a quadratic sequence. And the way we do that is by finding the first differences and then the second differences. So the first differences here will be 1.5. 4.5 minus 2 is 2.5. 8.5 minus 4.5 is 3.5. And 12.5 minus 8 is 4.5. So these are the first differences. The second differences, it will be 1.5 and 2.5. This will be 1, 1. So the second differences are 1. Now we should know from here that the A coefficient in our expansion is always half this second difference. So our A should be 1 over 2. But we won't guess this for the moment. We'll try to work it out. But it can be used to save us a little bit more time in an exam situation. So the way I would do it, just as we did it in the earlier part of this video, for for n equals 1, I have A plus B plus C is equal to 0.5. For n equals 2, I have 4A plus 2B plus C, which is equal to 2. And for n equals 3, I get 9A plus 3B plus C is equal to 4.5. So these are my equations 1, 2, and 3. If I subtract, I'll do it on the right hand side here. If I subtract the second one from the first one, I'll get 3A plus B is equal to 1.5. If I subtract the third one, the bottom one from the middle one, I get 5A plus B is equal to, again, 1.5. Is it 1? It's 2.5. And now, with these two equations, I subtract the top one from the bottom one, I get 2A is equal to 1, which gives me A is equal to half. Now, once I have A, I can work backwards. I have A is equal to 1. If I put it in this top equation, in the top one, in the 3A plus B, I get 3 over 2 plus B is equal to 1.5. This is 1.5 plus B is equal to 1.5. So our B here will be 0. And if I substitute all of it in the first equation, which I have A plus B plus C is equal to 0.5, I have A is equal to 0.5, B is 0, plus C is equal to 0.5. So this will give me C is equal to 0, 2. So our sequence, which I'm going to write in red in this space here, our sequence is half n squared, because B and C in the general form, like if we look at an squared plus bn plus c, b and c were 0 in this case. So our sequence is just half n squared. Now you can check, if you substitute 1 for n, you'll get half. If you get 2, you get 2 squared, which is 4 divided by 2, which is 2, and you get all the other terms. Please give this video a like. I'm going to do another one on linear sequences, which is obviously much simpler than this. But click on the subscribe button so that you get alerts when I put up new videos. Thanks for watching. See you in the next video.